From the November 2020 grade 12 question 8. O is the center of the circle. KOM bisects chord LN and MNO is equals to 26. K and P are points on the circle with NKP equals to 32 degrees and OP is drawn. M2 is equals to 90 degrees. And this is because OM is a line that is drawn from the center to the midpoint of chord. And then O2 is equals to 64 degrees because this arc right here, it subtends O2 at the center. It also subtends K1 at the circumference. So the angle at the center is 2 times the angle at the circumference. 8.1.1 A. The size of O2 is equals to 2 times K1. Angle at the center is equals to 2 times the angle at the circumference. So O2 is 64 degrees. Then B. So we said that M2 is equals to 90 degrees because the line drawn from center to midpoint of chord. Okay, so this whole angle should be equals to M2 plus that 26. The exterior angle of a triangle is equals to the sum of the interior opposite angles. So O1 plus O2 should be equals to M2 plus ONP. And the reason for this is triangle is equals to the sum of the interior opposite angles. O1, O2 is 64 degrees, M2 is 90 plus 26 degrees. Therefore, O1 is equals to 52 degrees. 8.1.2 Proof giving reasons that OKP is bisected by KN. So if I can prove that K2 is 32 degrees as well, then KN bisects OKP. In triangle OKN, I can see that OK is equals to ON. And this is because they are both radiuses. So here from to there, and then ON is also a radius. So this angle should be equals to that angle. So we would say K2 should be equals to ONK. Then this is because of the radii. K2 plus ONK plus KON is equals to 180 degrees. And this is sum of angles of a triangle. So we said K2 is equals to, so we would say 2K2 plus, so that's 64 plus 52, because that's what O1 is. So this is 170. =64 plus 52. It's 116. It's 116 degrees. So 2K2 should be equals to 180 minus 116. I'm getting 64 degrees. Therefore, K2 is 32 degrees. So this simply means that Kn bisects OKP. 8.2. In triangle ABC, F and G are points on the sides of AB and AC respectively. D is a point on GC such that D1 is equals to B. Okay. And then 8.2.1. If AF is a tangent to the circle passing through points FGD. So we have a circle that passes through points, those points. Then prove giving reasons that FG is parallel to BC. So this will be the tangent, and that will be a chord. So this means that F1 is equals to D1 because of the tan chord theorem. And since D1 is equals to B, then B will be equals to F1. So this will be parallel to that. So 8.2.1. We are saying F1 is equals to D1 because of the tan chord. But D1 is equals to B. We are given. This means that F1 is equals to B because they are both equals to D1. Therefore, FG is parallel to BC. Then this will be corresponding angles. 8.2.2. So now we have this line being parallel to that one. And then it is further given that AF is 2. And then FB, that's a 5. AC is 2x minus 6. So that whole length is 2x minus 6. And then GC is equals to x plus 9. This is x plus 9. And then they want us to calculate the value of x. So in triangle ABC, we are given the length of AC all over GC. So AC corresponds with AB, and then GC corresponds with FB. And this is because of the line parallel to one side of a triangle. And this is because FG is parallel to BC. AC is 2x minus 6. And then GC, that's an x plus 9. AB, that's 7. Because I'm going to add this with that to get the whole of AB. And then FB, that's just a 5. So this is 10x minus 30, which is equals to 7x plus, this is 63. So this is 3x, which is equals to 63 plus 30, which is 93. Therefore, x is equals to 93 divided by 3. So x is equals to 31 units. question 9.1 is a proof, and then 9.2. Chord QN bisects MNP. Chord QN bisects MNP. So this angle is equal to that angle. This angle is equal to that one. And intersects chord MP at S. The tangent at P meets MN produced at R such that QN is parallel to PR. Let P1 equals to X. So P1 is equals to X. So this means that Q2 should be equals to X because of the tan chord theorem. And then M and P, Q is a cyclic chord. So this means that M2 is equals to X as well. And since I am given that this line is parallel to that line, it means that P1 should be equals to N2 because I have that. So this angle should be equals to that. So this is equals to X, and that is equals to X as well. So this means that P3 is equals to X because of angles on the same segment. Okay, 9.2.1 E. Determine the following in terms of X. Give reasons. N2, we said that P1 is equals to N2, which is equals to X because of alternating angles, given that GN is parallel to PR. And then P1 is equals to Q2 equals to X, and this is because of the tan chord theorem. 9.2.2. Prove, giving reasons, that Mn over Nr is equals to Ms over Sq. So we go to the sketch and then we look for Mn. This is Mn. And then we are going to look for Nr. So Nr is there. Ms, Ms. This is Ms. And then Sq. Sq. So as it stands, this sketch doesn't really make sense, because yes, in this triangle we can complete, but we have a line here and a line there that are like in two different triangles, and there's no way for us to form a triangle using these two lines. So it means that there must be two lines that are equal to each other. So let's try and do this. So we'll have a line there, and then I'm just gonna use triangle QSP. And then I'll say in triangle MNS and triangle SQP. So we know that MSN is equals to QSP because of vertically opposite angles. And we know that M2 should be equals to Q2 because they are angles on same segment. And then N1 is equals to P3, angles on the same segment. So this means that triangle SMN is similar to triangle SQP. Angle, angle, angle. And then now we're just gonna do a ratio. SM, so we say SM over SQ, and then MN all over QP. So SM all over SQ should be equals to MN over QP. And then SN should be equals to SP. And then we check that. So we have MN over, we don't have QP, okay. And then we have MS over SQ. So it means that MN over QP should be equals to SM over SQ. And this is because of similar triangles. But there we have an NR instead of a QP. So it means that NR should be equals to QP. Or NR should be equals to another length somewhere in triangle SQP. So let's just do this. NR is right here. Okay. So R is equals to N1. And this is because of corresponding angles. Because I have QN parallel to PR. So now I know that this side is equals to that because this is equals to X. Okay, so QP is equals to NP because this is equals to X as well. Opposite sides equals to angles. So it means that NR is equals to QP. So NR is equals to NP, which is equals to QP. So this means that MN over NR is equals to SM over SQ. Question 10. In the diagram, a circle passes through DBE. Diameter ED. So we have a diameter, it means that B2 is 90 degrees. Of the circle is produced to C, and AC is a tangent. AC is a tangent. So this angle right here is equals to that angle. Okay. M is a point on DE such that AM is perpendicular to DE. AM and chord BE intersect at F. Then 10.1.1. Prove giving reasons that FBDM is a cyclic quad. So FBD, so this must be a cyclic quad. And it is a cyclic quad because this is 90 and that's 90 because of the exterior angle of a cyclic quad. So we'll say B2 is equals to 90 degrees because it is an angle in a semicircle. And then this means that B2 is equals to M2. Therefore, FBDM is a cyclic quad. Exterior angle of cyclic quad is equal to the interior opposite angle. 10.1.2. We need to prove that B3 is equals to F1. B3 is equals to F1. In triangle MFE, F1 plus M2 plus E equals to 180 degrees. This is the sum of angles of a triangle. F1 plus 90 plus E is equals to 180 degrees. So this means that F1 is equals to 90 degrees minus E. But E is equals to B1. That's because of the tan chord. So F1 is equals to 90 degrees minus B1. B1 plus B2 plus B3 is equals to 180 degrees, and they are angles on a straight line. B1, that's just B1. B2, that's 90. B3. So B3 is equals to 90 degrees minus B1. So yes, F1 is equals to B3. 10.1.3. Prove that triangle CBD, so in triangle CBD and triangle CEB. So let's go and draw our triangles CDB, CDB, and then the other triangle is CBE, CBE. So C is equals to C because it's common. And we can see that B1 is equals to E because of the tan chord. So this means that D1 is equals to CBE. This is the third angle of triangle. So triangle CDB is similar to triangle CBE. Angle, angle, angle. 10.2. It is further given that CD is equals to 2 and DE is equals to 6. Calculate the length of 10.2.1 BC. So we'll use triangle CDB being similar to triangle CBE. This over that is equals to this over that. So CD over CB is equals to DB over BE, which is equals to CB. So this is CB over CE. And then we are looking for CB. And then we are given CD. Well, CE is just CD plus DE. So this is CD over CB, which is equals to CB over CE. So CE is this whole thing, which is 2 plus 6. So this is because of similar triangles. CD, that's a 2. Oh, okay, let's just fix this. This is CB squared, which is equals to CD times CE. So CB is equals to CD, that's a 2, and that's a 8. So that's a 16, so it's 4 units. 10.2.2. So now they are looking for DB. So they are looking for this length. Okay, and then I have a right angled triangle right there. And then I do have DE. DE is 6. DB, that's what I'm looking for. BE, I don't have BE. Okay. DB over BE. So I'm using this again. I can choose any of the two. Should be equals to. So I want to choose something that is available there. DB and then CE. No, CE. DE. Okay. Let me just do this first. So I know that DE squared should be equals to DB squared plus BE squared. And this is because of the Pythagoras. DE, that's 6 squared, which is equals to DB squared plus BE squared. So I'm going to say DB over BE should be equals to CD I do have and CB I do have as well. So this is CD over CB, and this is because of similar triangles. DB, that is, no, DB, do I have DB? DB, that's what I'm looking for. DB over BE, that's what I'm searching for. So CD is 2, and then CB, that's a 4. So DB over BE should be equals to 1 over 2. Therefore, BE is equals to 2 times DB. So I'm just gonna go back to this and say 6 squared is equals to DB squared plus BE is 2 DB squared. 36 is equals to, so this is 1 squared plus 2, which is a 5 DB squared. Therefore, DB is equals to square root of 36 over 5. So I'm getting 2.68 units.